Hello, I'm Dave Casler, amateur radio call sign KE0OG, your guide through the ARRL license manuals. The videos in this course follow the manuals section for section. You can get the ARRL license manuals from the source listed below the video. After you watch the video, dig into the corresponding section of the book, study the associated questions, and then come back for the next video. I'd like to start this discussion about satellites with something that's not in the book, and that's this amsat.org. AMSAT is the website you want to go to for absolutely everything pertaining to amateur satellites. Amateur satellite, okay? And there are amateur satellites put up by people all over the world. The AMSAT organization publishes this book, Getting Started with Amateur Satellites. I picked this up at Dayton last year, and it's got just everything you want to know about satellites, how to use them, and it actually goes through the satellites that are currently actually on orbit and all the special stuff about them and so on. There are quite a few satellites in orbit that are amateur satellites. These satellites are built by and operated by radio amateurs. Now, one of the very first questions that's in the book, who can be the control operator at a station that's communicating through an amateur satellite? The rule is, if you have privileges for the uplink frequency, it doesn't matter what the downlink frequency is, you're okay. In practice, all the uplinks these days are in the UHF, VHF bands anyway, so you're okay. Now, let's look at a few definitions of things. We can look at an FCC definition that can be very confusing. Okay, suppose this is Earth. Okay, there is an imaginary line above the Earth at 50 kilometers, and according to the FCC definition, any radio station above that line is a space station. Now, let's talk about this. There's something up there called the International Space Station. That term space station and this term space station are different. The FCC is talking about a radio station located above 50 kilometers as being a station in space, or space station for short, which is very confusing because we have the International Space Station. The International Space Station is, by the FCC definition, a space station. But other satellites like Dish Network and so on are technically space stations, but we don't call them that. Okay, so this is kind of an arbitrary definition. By the way, the generally accepted limit of the start of outer space is at 100 kilometers. And even 100 kilometers is a little too low to actually orbit a satellite because there's enough atmospheric resistance that the orbit will decay very quickly. And certainly at 50 kilometers it's not possible. Now, the thing is, of course, aircraft cannot fly that high. So there's this band in here, sort of nobody's land, that separates Earth from space. All right, so that takes care of space station. The satellite beacon is just a radio signal the satellite puts out, usually the telemetry beacon, and it contains all of the measurements. Telemetry, the tele means far, metry means measure. It's the measurements from the satellite going to the ground. Doppler shift is a kind of an interesting concept. We're all familiar with the idea of a train going past a crossroads. The horn sounds higher pitch here, and then as it goes by, the pitch of the horn suddenly drops. Everybody's familiar with that concept. It's called a Doppler shift. Now, if we look at that in a satellite, if you're standing here on the Earth, as the satellite comes this way, you're going to hear it transmitting on frequency F, but you will get a little bit of a Doppler shift, which will mean that the frequency will go up by a little bit. As the satellite passes this way, the frequency that you hear will be minus the Doppler shift. This becomes important if you're using AM, sideband, CW, something like that through a transponder. Your frequency will shift. A lot of amateurs just listen to their own signal in one ear and then keep adjusting the radio so that it stays at the right frequency so that they can adjust for this. Okay, because it affects both your uplink and downlink signal. And if you've got another amateur in some other location, they're affected differently. So keeping track of that can be interesting. On FM, it doesn't really matter so much. Okay. What causes spin fading of satellite signals? Well, satellites, let's take the little CubeSat. Okay, got an antenna sticking out. Usually what they'll do is they'll spin these satellites if they can to keep them stable. They act like little gyroscopes to keep that antenna constantly in one position. But if you've got any satellite tumble, this antenna, you know, starts moving around like this, and you'll see that as fading on Earth as the polarization changes. Okay, and plus the antenna can actually tip away from you or toward you, and so on, and can cause problems. Okay, there are several different kinds of orbits. There are low Earth orbits, which tend to be really fast. They're called LEO, low Earth orbit. Okay, so most amateur satellites are this way. The space station is this way. Lots of satellites use low Earth orbit, weather satellites, things like that. There's something called medium Earth orbit. Now, let me step back. The LEO satellites take minutes to a couple hours to circumnavigate the Earth. The MEO satellites take hours to circumnavigate the Earth. Up here you've got things like your GPS and GLONASS and Galileo and things like that are up there. And then there is a special orbit out here called GEO, and it has an orbit period of about 24 hours, and the Earth, of course, has a spin of 24 hours, so it always appears that the satellite is above the same place on Earth. There are no GEO amateur satellites yet. None that we've seen. There are technical reasons why we don't do that. Basically, it takes a pretty big setup to make something like that work. Okay, now the International Space Station, which I mentioned is a space station, the ISS, with all of its accoutrements here, and you're down here, over the US, if you listen on 145.800 FM, you may hear the space station. That's the downlink frequency they use in the Americas. The uplink, if they happen to call CQ or something, the uplink is 145.990. Note that this is not a repeater offset. This is operating split, okay? But it's nice. You just tune your normal FM radio with an outside antenna to that frequency, and you may hear the space station from time to time. Now, the way that we track satellites is there was a guy who developed the orbit theory by the name of Kepler, lived several hundred years ago, and Keplerian elements are a set of numbers that describe an orbit. And these are the Keplerian elements. And if you have these, you can put these in your favorite orbit tracking program, and it will tell you where the satellite is or will be. Now, what's easier is just going to the AMSAT.org website, looking up the satellite, and it will tell, and you put in your location, it will tell you when the next several passes are, where you need to be, where you need to point your antenna, and so on. Now, in amateur practice, we point our antennas based on where the satellite is supposed to be based on its Keplerian elements, rather than try to track it. So, just a couple things at the end. Telemetry information transmitted by the satellite beacons is the health and status of the satellites. Some satellites are FM up, FM down. Others have what are called transponders. A transponder takes a stretch of bandwidth, say on 2 meters, and it will transmit it out on 70 centimeters. Actually, it's usually the other way around, but that's okay. And this bandwidth is just repeated. So if there's a little signal right there, you'll see a little signal right here. It usually inverts them, by the way. If you put an upper sideband signal here, it'll come up lower sideband over here. Now, the problem with this is that the satellite has only a certain amount of power, say 10 watts, to put across the whole band. So if you get a great big signal in here, you'll get a great big signal in here, and it'll hog all the power. So that's why you need to make sure to manage your uplink power so that it seems about the same as everybody else's, so that you don't end up hogging all the power and shutting everyone else down. Doing so is a real faux pas. You don't want to do that. It is poor amateur practice to do that. You get through, but nobody else does. You need to make sure that your signal seems about the same as all the other signals so that everybody has a chance to use it. Okay. Let's talk about another confusing term called mode. Mode has two meanings. Mode one, it's the up versus down frequencies or bands. So a UV mode satellite goes up on UHF, comes down on VHF, and that's called a mode. Okay, the other meaning of the term mode is what we think of normally: CW, USB, LSB, AM, FM, and so on. Okay, so you'll hear this term used in two different ways. Make sure that you know which way that you're trying to look at it. So mode UV would be up on UHF, down on VHF. Who can receive telemetry from a space station? Anybody, of course. All you need is a radio to listen to it. Occasionally, when one of the satellites is having trouble, the operators of the satellite will ask for people around the world to record the beacon information, the telemetry information, and send it to them so they can get a better picture of what's going on the satellite rather than just during their very short pass that they might have. So I think that covers satellites. Thanks for following along with the videos and the book. After you've studied this section in the manual and are satisfied you understand the questions and their answers, come back here for the next video. The ARRL is the National Association for Amateur Radio, and I urge you to join, even if you don't have your license yet. That way you get QST, the League's monthly magazine full of articles for beginners and veterans alike, or you can choose On the Air, a magazine designed specifically for those new to amateur radio. Until we next meet, 73.